Okay, let's continue with our PIR motion sensor number 2. And this just jumps right into the test code. And it says, move your hand in front to test it. Move your hand in front of the sensor, the LED will turn on. After 5 seconds of immobility, the LED lights turn off. So let's see what this means in real life. So we define the pyroelectric at 14, and we define the LED Y at 12. So we're defining basically a variable. We named it, but it represents the device. Let's see. So we define two devices. We have our setup, void, no return type, serial begin, 96 bauds. Pin mode for the pyroelectric is an input. Pin mode for the LED-Y is an output. Let's get down here in our loop function. So the purpose of this is to set the pin output. Let's see, expand that. Okay, a little bit so we can see all the code. Set the pin as an output mode Boolean. Pyroelectric value equals digital read so that it's just telling us what we're wanting to do. Okay. So serial pin or serial print, it's going to print. Excuse me, I just lost my headset again. Okay. Serial print pyroelectric value, and then serial print the overload. This is the actual value. So this is just text within quotes, and this is the actual value. And then we delay 200 milliseconds. And then we have an if statement. If the pyroelectric value is equal to 1, and remember, this double equals sign right here is testing for equality. It is the single equals sign is an assignment operator, meaning right up here, this code up here, well, it's a comment, right? But this is assigning the value of digital read of the pyroelectric device to this pyroelectric value variable. It's a Boolean. This is an assignment operator. This operator tests to see if this is equal to 1. And so if it is, we digital write this hardware as high, and that turns on the LED. And if not, the else, we digital write the hardware as a low, and we turn off the LED. So let's go ahead and do that. This is interesting, because now we have an error message. Let's see what it says. New sketches, in function, void loop. New sketches, 12 to 18. Pyroelectric val is not declared in this scope. Did you mean pyroelectric? So it's saying oh, see, this goes down here. So that was a mistake that I made when I copy and pasted the code, and that happens quite frequently in coding. So this is why we are actually going through here and reviewing everything line by line instead of just accepting it for what it is. I'm going through and I'm reading the code and trying to figure out what it's going to do. So what exactly is going on here for those of you who don't know? Most of you who are accustomed to code know exactly what's going on. But for those of you who are new to this, here's what's going on. These two lines right here are saying that everything after them is a comment. So the program, the computer's not going to read any of this as part of the program. This is only here for human beings to read. Okay? Now, this is the folly when you copy and paste code and you don't know what it's supposed to be doing. Is because this actually belongs down here. We talked about that is not part of the That's not part of the note for the people. This is telling us we want to create a Boolean variable and name it pyroelectric value and assign it the value of digital read of the device. So this needs to be down here. It's not part of the comment. That is a very easy mistake to make when we just copy and paste code without really understanding what it's trying to do. That's why we ran into this error. So I'm willing to bet, see if I'm wrong, willing to bet that if we do that, now it's going to work right. As you can see, we're getting stuff that's supposed to be happening now. So let's back this off a little bit. And now when we trip this thing, we should see some sort of a light come on. Yep. Let me change this up a little bit. There. Let me turn off my lamp, because now you can clearly see that the red light's on, and when we trip it, the red light goes off, the state changes. But more importantly, let's take a look. I don't think we're printing anything to the console, are we? Yeah, we are actually. We're sending that value to the console. We just talked about that. I was ignoring what I had said earlier. But there we see evidence in the console that the state changes, and we also see this. Now, what if we're actually building this device for somebody, right? We're building this device for somebody. We actually, let's do this. Oops. Let's do this. This is another way to comment blocks of text. Okay? And we're just going to do this part for fun. So what I've done is I've blocked out the serial print functions. And now we're loading everything back up again. And it's working just fine, right? So what's our difference here? Let's go and let me smallen this a little bit. And so we're back, and we see we have our red light, we see our toggling and everything, but we don't see anything printed out to the console, right? Why is that? Or why do we care? Why are we bothering with any of that? Well, here's why. When we print to the console, it's like a debugging tool, right? So, for example, if you have a video game or something, and the specs say, oh, this game is like, several gigs of da-da-da-da-da. This game is 5 gigs to install on your computer. Well, every little bit of this is a byte. Every little bit of this is a piece of information. Every little character is a piece of information, and that includes all the white space. It includes all of that stuff. Even though white space, like this piece of white space right here, even though it's just nothing and the computer won't read that as part of the program, it will just ignore that, exemplified by if we take that out and we run it, it's still going to run the same way. But it still counts as an ASCII character, and it takes up information. So having that in there is an inefficiency in some ways. So what we're doing is this code is not optimized for production. So as a developer, we might put in things like these serial values that need to be used as we test for the code. But when we put this into production, in order to make the file smaller, we'll cut stuff like this out because nobody's ever going to see it again. Odds are, if I'm selling this type of thing as a device, right? If I'm selling a video game to a customer, they're not going to go into the code. The average customer is not going to go into the code and look for these properties like this. If I play a video game on Nintendo, I'm not going to open up the code. I'm not going to go into Unity Engine and look for all of these test things. They just don't need to be in there in final production. So We put things like this in here to make sure that things work, but then, and even comments like this, we take those back out when we get ready to ship it. Like, you know, when we're shipping the final thing, we'll take out all the comments because these take up space, these take up room, these bloat the program, and these help it run less efficiently. If we remove all these characters, it's just less data that everything needs to be looked at. So, you know, if we have a whole big, huge video game and it's loaded with all of these comments and stuff, well, if we take out all the comments and all the test stuff, that'll get it down to like 5 gigs for the stuff that you really need to have for like a 3A game, right? But if we leave all this crap in there, then it's going to be like 10 gigs, you know, or more, because it's just got all this stuff that the player doesn't need. You know, player doesn't need serial print. So anyway, that's what we've been doing. So now we've got input interfacing with output, and we did that yesterday with our beginning things, with our buttons and input device, turning on the light, things like that. And that's been overridden, so that function is no longer working because now we're messing with this one. But okay, so anyway, we've explored the PIR motion sensor and talked a little bit about that for a while. The next one, I'm not necessarily against this idea, but the next thing we're going to do is play with the piezo buzzer, and we are going to teach it how to play Happy Birthday, which is not necessarily a royalty-free song. So that's neither here nor there. That's our next video. We'll look at the piezo buzzer, see what makes that thing work.